All right, let the adventures begin here in chapter 5. 5 is actually reviewing something that you learned in Algebra 1. It's going to be the rules of exponents. They actually can be a little tricky. You really have to take your time and walk through the steps and make sure that you learn some of these main rules. So let's refresh your memory a little bit. We're going to look at examples and then kind of general rules. What you can think about, keeping in mind that when you have exponents, this is the base and this is the power. This is going to be the thing that gets repeated. This tells you the number of times to repeat it. So, for example, b to the second means b times b, and then b to the third would be b times b times b. So all of them together turn out to be b to the fifth, but the easy way to do that is to add their powers. So our rule is going to be that when you are doing the same base, like here, a and a, multiplying them together, but they're two powers, you actually add the powers because of that example above. So then here, if I do kind of the same thinking, I'm going to have 1, 2, 3, 4, 5 c's multiplied over 1, 2, 3 c's multiplied. Each cancels, leaving me with c to the second because there's two of them. The easy way to do that is, instead of writing it all out, is you would take that top minus the bottom. You're basically canceling out, but it ends up subtracting the difference between the 5 and the 3 is where that 2 came from. So that's going to be that rule for if you have a power over the same base to another power. So this one, you may remember from Algebra 1 what you're going to do with these. You're going to ultimately end up multiplying them together. So when you're bringing in a power from the outside of parentheses, it's going to end up getting multiplied by the other powers. Here's why. This would be c to the 3 written 4 times, multiplied by itself 4 times. But then if we use our rule from earlier on, we would be adding this 3 plus this 3 plus this 3 plus this 3, and that's where that 12 comes from. But the easier way to do that is to multiply the 4 on the outside times the 3 power that's on the inside. So these boxed in ones are going to be like the rules that you have to start to know and have in your toolbox for simplifying or applying the exponent rules. Here, if you have, like they used k and l and squared it, squaring means multiplied by itself. So I'd end up with k times k and l times l. So ultimately that, right now they're both to the first power. So this 2 gets distributed to the powers that are in there, and everything inside the parentheses is affected by that power, which is kind of like regular distributing. Just remember that if there's a number in there, that what you're distributing is just a power rather than a regular old number. What I'm trying to say is if I had 3x squared, this would not turn into 6. It would turn into 3 squared, which would turn into a 9x squared. So that's what I was trying to say. Here, this is basically going to tell me I'm going to be distributing that power again to everything in there, just like we just talked about, but now it's also going to be true for division, because in this example, I would have m to the second to the fourth, and on the bottom, n to the fourth. So then I'd end up with m to the 8 because of our previous rule from up here, and then n to the 4. So it starts to get to the point where there's several rules kind of taking place at once. Think about how repetition works. 2 times 2 times 2, that would turn into 8. But to the second power would just be a 4. 2 to the first is just going to be a 2. And then any number to the 0 power is 1. Any number. So that's this rule is saying, hey, anything to the 0 power is 1. So whenever you have a number, a variable, anything that is to the 0 power, it's going to have a value of 1. 3 squared is going to be 3 times 3, so 9. And then you would here end up with 3 to the first. And so to get from here to here, you're dividing by 3. 3 to the 0 is 1. You're dividing by 3, because since powers are repeated multiplication. To go backwards, you end up dividing. Same thing over here if I looked at these numbers. To get from this 8 back down to the 4, you would have divided by 2. To get to here, you would have divided by 2. To get to here, you would have divided by 2, because that's what you were multiplying by on the way up. So what's tricky here is this is taking one additional step, and you would divide it by 3 and end up with 1/3. And that is going to bring us to a kind of tricky rule, and that is if you have a negative power, it actually, right now, this A is like over 1, because it's not over anything. And so it ends up kind of flipping that over, and you end up with 1 over a to the n power, and it becomes positive once it flips over. So negative powers, they don't make things negative. They just move that thing from the top to the bottom or back. So let's see how that all kind of plays out in some of these problems. So this is 1 over 2 to a negative 1. So that negative power has to move to the top. And now there's nothing left on the bottom, so it would just turn out to be a 2. Here, this 3 to the negative 2 has to move into the bottom and become positive 2 power. This 4 to the negative 1 power on the bottom moves to the top to become 4 to the positive 1 power. So I end up with 4 over 9. These can definitely be tricky. Here, using my rule from how I distribute the powers from up above, I'm going to go ahead and get 2 to the negative 1 over 3 to the negative 1. So this has to move down to become positive, and this has to move up to become positive. And so 3 over 2 is my final answer. So these rules right here are specific cases of really just this. Like this is saying, what if I have 1 over a negative? Well, now it's going to move to the top and become positive. But that's just a specific rule or situation of, hey, if you have a negative power, move it to the top if it's on the bottom. If it starts on the bottom, move it to the top. So in this particular case, since this is negative, it would move on to the bottom and become positive power. And since this is negative on the bottom, it has to move to the top and become positive power. So it's flipping it over because that negative basically reciprocates, flips it over. Again, anything from the top goes to the bottom. So this is just another specific case, because if I distributed that negative power, then this has to go up to become positive powered, and this has to come down to become a positive power on the bottom. You really cannot have any negative powers in your answer. So just kind of as a reminder, when you get to doing these problems, your answers should have no negative powers. You got to move them and make them positive. So if your answer has a negative power, it's definitely wrong. And so you want to fix that. It also can have no repeat variables, meaning you should not have x written twice in the problem. So like if you look at these problems, the first one has a written several times. It should be worked out, simplified to a point where you do not have that a repeated. So I sort of have an order that I do these in. Because some of them have a lot of steps. Like these last ones, a lot of steps. Here's the order that I do them in. First thing I do is I distribute powers that are outside parentheses. Secondly, I move anything with a negative power, not a negative number, but a negative power. If it's in the bottom, I move it to the top. If it's in the top, I move it to the bottom. Now it'll have all positive powers. Third, I look across from side to side to combine anything that has the same base, and I'll show you what I mean in these problems. And then lastly, I look from top to bottom to cancel out any repeat variables. So those are the 4 steps I take. 4 is like the max. You don't normally do all 4 steps, but that's just the order I approach it. If you did it in a different order, you would still hopefully come up with the same answer. I just like to do them all the same. So currently, this isn't over anything, so it's all over 1. I'm going to follow my own advice. There's no parentheses, so I'm not going to do that step, but I am going to move negative powers. So anything negative has to switch power. My pen is not working. So this, the -7 power, the -2 power, they'll have to move, but the +5 won't because it doesn't have a negative power. So I'm going to end up taking this and move it down, this and move it down. And so at that stage, I'll have my a to the 5 that didn't move. I'll have an a to the +7 and an a to the +2 on the bottom. Then my third step says to look across, like side to side, and see if anything combines. Well, the top doesn't have anything except that a to the 5. But on the bottom, if I look side to side, these two are the same. And so because they're getting multiplied, I actually add their powers, and I would end up with this. And then the last step says to look from top to bottom to cancel. Now, subtraction gets tricky here because if I did 5 minus 9, it would be negative. So what I always think of it as is you have 5 on the top, 9 on the bottom. They have 5 in common that would cancel out. The difference between them would be 4. And those 4 extras go wherever you had the most. So in that particular problem, you have the most in the bottom by 4. Because up here I'd have 1, 2, 3, 4, 5 A's. And on the bottom I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if all 5 of these cancel out, I don't have anything left on the top, so I use a 1 as a space holder, and then I have the 4 left here. Sorry, it's messy. Okay, this one looks confusing, except that this whole thing is to the 0 power, and anything to the 0 power is 1. So since the whole thing is to the 0 power, the whole thing is 1. This -3 is chilling out front, so this 4 power is only going to get distributed to these guys. Now, be careful. This does not become an 8. The power does not interact with the regular number. This used to be 2 to the 1st power. Now it's 2 to the 4th because 4 times 1. This used to be m to the 1st. Now it's m to the 4th. So if you use your power chart or your calculator or whatever, 2 to the 4 is going to be 16. And then now these two, now that I've gotten rid of the exponent and everything else because PEMDAS is real, I did parentheses, exponents. Now I'm going to multiply, so that -3 and that 16, those are going to get multiplied together. And then when I'm done, I look and I go, okay, I don't have any repeated letters. I don't have any negative powers, so I must be good. Here, like my 4 steps, I'm going to distribute the power. And again, this is 3 to the 1st power. Don't multiply the power by the number. Don't get 9. So I have now 3 to the 3rd, x to the 6th, because the powers multiply as you bring that power in. And on the bottom, I haven't done anything yet. 3 to the 3rd becomes a 27. And now I'm going to take a look here and be like, all right, I need to reduce this. And I can reduce it by 3 because 3 goes into both. So I get 9 over 2. And then looking at the x, I have 6 on the top, 5 on the bottom. That's a difference of 1. And that 1 extra would go on the top because that's where I had the most. So that's where my extras would be. All right, these are getting multiplied. I'm going to actually just go ahead and multiply everything first. So 7 times 3 is 21. This a to the 8 and a to the -9, if you had that as its own problem, you would add those powers, so it actually ends up being to the -1 power. And then here, you would have b to the -3 times b to the 3rd, which would be to the -3 plus 3. So that actually becomes b to the 0, which is just 1. So those just go away. Now I'm going to move that -1, a to the -1 into the bottom. Now I don't have a bottom, but I'm going to. So my 21 sits there because it doesn't have a negative power, and my a goes to the bottom. Okay, I don't remember doing that on the filled in notes. I feel like I might have missed that one. Here, I don't have any parentheses. I don't have any negative powers. Going left to right, I have an M and an N, so those don't combine. So I actually only do the last step, which is look top to bottom and cancel. So here's my M's. I have 1 on the top, 3 on the bottom, so that's a difference of 2, and they'll end up on the bottom because that's where I had more to begin with. For N's, I have 4 on the top, 1 on the bottom, so I'm going to end up with 3. Because 4 minus this one. And again, it would be like having 1, 2, 3, 4 N's, 1 on the bottom, 1 cancels. I'm left with n to the third on top because that's where the extras would be. Now these last two are doozies for sure. I'm not even sure I'll have enough space here to show what I'm doing. I'm going to start, like I said, by distributing this power. And first of all, this is going to reduce to 1/3. So I'll probably just do that now. So I'm going to have on the top a 1 and on the bottom a 3. When I distribute the -2 to the x, I get x to the -6. I'm multiplying the powers. The y actually turns into a +4 because of -2 times -2. And then the z is going to have a -8 because -2 times 4. In the bottom, I'm going to distribute the 3 as a power. So I end up with x to the -6. The y has a -1 getting multiplied by 3, so -3. And the z, the 2 and 3 multiplied become a 6. Now I'm going to move anything that has a negative power. So this is going to move down, this is going to move up, this is going to move down. Everything else stays where it was. So my 1, which I really don't need to write, that y to the 4th that was there before, these guys are all staying. Oops, I missed one. Because this y down here to the 3 is also negative. And in the bottom, the only thing that are staying put is the 3 out front and then that z to the 6th. So the things that moved, this x to the -6 moves to the bottom to become positive, but this x to the -6 that was on the bottom moves to the top. This y to the 3rd that was on the bottom and negative moves to the top to become positive, and this z to the -8, which was negative on top, moves to the bottom to become positive. So now I got rid of my negatives, and now I'm going to look here and see if anything combines. I have x to the 6th, and then I have 4 y's, 3 more y's, so 7 total. On the bottom, I have my 3. I do not have any other x's or y's, but these, I have a z to the 6 and a z to the 8, so together they would make z to the 14. But then my last step, and this one had all 4 steps, I'm going to have to go ahead and multiply those, cancel those out, because 6 on the top and 6 on the bottom would cancel out completely. So I end up with y to the 7 over 3z to the 14. All right, same process here. Keep in mind, I sometimes draw in powers of 1 so I don't forget that the 2 does not multiply with the number. I don't get 8. It becomes 4 to the 2nd, and then x to the 2nd. With the y, the 2 power and this other 2 power become a 4. And here, that z becomes -6 because there's nothing to change the sign. This is going to be a -1 power to each. So this becomes 4 to the -1. The x was a -1 power, so when I multiply it by this -1, it becomes positive. My y was a positive 3 power, but when I multiply it by -1, I get this. And then my z is to the 5, but when I multiply it by -1, it's -5. So these are the ones that are negative powers and need to move. So that's going to go up, that's going to go down, these are going to go up. So let's try to keep track of that. First of all, 4 to the 2nd power is 16. I have my x squared and my y to the 4th that don't need to move. And then I'm moving up this 4, so I'm going to have another 4. I'm moving up this y to the 3 and z to the 5. On the bottom, I have this x, but I'm moving down that z to the 6th. So now that I've got all my negatives gone, 4 times 16 is going to be 64. Looking side by side, these two can go together. So I have y to the 4, y to the 7. My dog's getting a really loud drink. It's really long also apparently. And then now I'm going to do my last step of looking from top to bottom, and my pen just died again because I'm just currently riding struggle bus, which is not new. I'm literally on the very last steps here and my pen died. We'll just juice it up for a nanosecond. That hopefully will do the trick. Okay, so that I have 2 on the top, 1 on the bottom, so when I cancel, it's left with 1. The y to the 7, there's nothing on the bottom to change it, and this was a y to the 6, excuse me, a z to the 6. So with 5 on top and 6 on the bottom, Dolly, stop drinking. There's only 1 extra, and the extra would go on the bottom where more were to begin with. So this is a tricky concept. We've done it before, but that doesn't make it easy. The key, honestly, is to practice and just, give yourself an opportunity to really get those back into your brain. Good luck, guys. Bye.